Hi, welcome to Batch Prep, your golden channel, by the way. Let's discuss data structures and algorithms. In the previous video, we discussed about what is a data structure and what are the operations related to it. And in today's video, we are gonna learn what is an algorithm. So let's make learning fun. Now, what is an algorithm? An algorithm is the step by step, unambiguous instruction to solve a given problem. Now, what do you mean by that? Suppose you want to cook something, you and you don't know how to cook. Now, what shall you do? You will see a cookbook or a recipe, right? And recipe is just the step by step procedure for cooking that dish. Isn't so? Yes, it is. Likewise, an algorithm is the recipe to solve a given problem, the step by step procedure. Simple? Yeah. Now, what are the features of algorithm? One, it should be complete. It should be a complete solution to a problem. Then, it must take finite steps. Okay, not infinite steps, finite. Then, it is unambiguous. What do you mean by this unambiguous term? Unambiguous means it is crystal clear. Okay, crystal clear. What do you mean by that? Suppose you are in your car and you you see the red light. Okay, red signal, traffic signal. Then what you will do? You will just stop your car before crossing the line. Isn't so? Yes, it is like that crystal clear. Unambiguity. Then it must take finite time, not infinite, indefinite, finite. Then it is a step by step procedure. Obviously it is. Then it must take no optional steps. Fine. Let's see. What is a problem? Now, a problem is a question that needs to be solved using a step by step procedure. What do you mean by that? We discussed that cooking example, right? Yeah, cooking is that problem. It is a question we don't know, but we know it can be solved by a step by step procedure called recipe or the cookbook. That is what it is, right? So, cooking is that problem. Now, for a problem, we need to know what input is given and what output do we get. What do you mean by that? What input is given? Like the cooking problem, we need to know what are the ingredients that can be an input to the cooking dish, and output is the cooking dish itself, right? Cooking meal. Yeah. Now problems are of two types. First, optimization problem. It gives output like that cooking. The cooked meal is the output. That is optimization problem. Then decision problem. Decision problem tells yes or no. What do you mean by that? Did you go to college yesterday? It is a yes or no question, right? Like that, it is decision problem. Okay. Now, algorithm is just the mapping between input and output. Now, let's deep dive into analysis of algorithms. Why is it even required, bro? It is. It is. I'm gonna tell why. And you are gonna enjoy it. So a problem has many solutions. Okay. Many solutions. Many. Now our duty is to choose what is the best for us. Best solution that suits us. Right? Likewise, here too, a problem P has many algorithms A1, A2, A3 up to AN. Okay, we have to select what suits it, right? What suits its performance. For example, a car. If you want to buy a car, okay, and there are two models in front of you with the same budget, okay, same price. Model F1's performance is average and models F2's performance is better. Now, what you will select? Obviously, the better one, right? The F2's model, F2 models. Therefore, analysis of algorithms is like this only. We have to select what performance will be better, which performance will it excel in, right? We need to know that. Okay, so performance of an algorithm in terms of what? In terms of actually time and space. Now, what do you mean by this time and space? Time means here CPU time, and space means here main memory space. Now, it's all about time and space performance, right? I get it, but no, not quite. Actually, it depends. Performance is based on the use cases. Now, what do you mean by that? For a von Neumann architecture based PC, we need to have an algorithm that consumes less time and space. For a distributed system, we need to have an algorithm which consumes less bandwidth. Similarly, for a mobile computing system, we need to have algorithm which consumes less power. Yeah, performance is based on the use cases, right? It is. Now, how to analyze algorithm performance? It is important, right? Yes, it is. Firstly, we have this a posteriori analysis. After developing the algorithm, after proper implementation, we analyze it. It tells the exact CPU time and it tells the exact space, the main memory space, right? Here in a priori analysis, before implementation only, we analyze the algorithm. It gives a upper hand before actual implementation, right? Yes, quite like that. It gives approximation time, that is a CPU time, and approximate memory space. Now let's jump into a posteriori analysis. We use system calls to measure the CPU time of algorithm, but there can be interrupts in multitasking operating system. So therefore, exact time calculation depends on the environment the algorithm is in. So it is tough and rough, right? Yeah, it is. Therefore, we need this a priori analysis. Now, before jumping into a priori analysis, we need to understand some important things. Okay. First, these properties of algorithm. Now, an algorithm should terminate in finite amount of time, not indefinite. Finite. Okay. It should produce at least one output. It should be. It should produce at least one output. Okay. It should take 0 or more inputs. Fine. Corresponding to given set of inputs, we must have fixed output. That is the mapping between input and output. So if we have an input, so we will be having fixed output, not dynamic. Like here it is now and next time it is here. It is not possible. It should not be it should not be dynamic. It should be static here. Static mapping. It should be platform independent, okay? And every statement must be crystal clear or unambiguous. Great. Now, what are the steps required to develop an algorithm? First step, problem definition. Identify and define the problem properly. Next step, development model. Make DFD, data flow diagram, or any other model to describe the problem graphically. Okay, fine. Then design phase. The identifies the steps in algorithm and write them in proper steps. Great. Next step is testing. Try to find error in algorithm by running various test cases. Step 5, analysis. Measure its time and space complexity. Fine, we will learn it. Next step, optimize. Try to optimize the algorithm by reducing time and space complexity. And the last step, implementation. Implement the algorithm in any programming language, either C, C++, Java, Python, etc. Now, why do we need this a priori analysis? Well, it's simple. Suppose you are in a preparation of any exam. You need one roadmap, right? A proper, well defined, optimal solution for ideal preparation before actual implementation, actual doing, actual grind, right? Yeah, this is what a priori analysis is. So, a priori analysis, how to actually analyze algorithm before implementation. First step, hypothetical language. Take a language to describe the algorithm. Next, hypothetical CPU having infinite memory. Sounds funny, right? But we have to assume it. Each fundamental operation needs 1 unit of time to complete its execution on this CPU. Each operation only 1 unit of time. Great. Now select a metric or a criteria for analyzing the running time of the algorithm. Okay, we will learn it. Then the last step, approach for categorizing the running time of an algorithm. That is asymptotic notations. These steps are called a priori analysis frameworks. Okay, fine. Now, a priori analysis, we have two methods. First is step count method, next order by magnitude method. Okay. Here in step count method, we need to understand that each operation needs 1 unit of time. Like we have this example over here, z equals x plus y. Now plus an assignment equals, there are two operations, right? So each operation needs 1 unit of time. So plus takes 1 and assignment takes 1. Overall 2 units of time are required. So here is one example over here. This is an algorithm. Okay. So first step 1, z equals x plus y. So it will take two operations, 2 units of time. Fine. Then we have this S2 for loop. For loop here I equals 1. It is an assignment operation. So one operation is taken. Then this comparison, this one. We have to do n plus 1 comparisons over here. So fine, n plus 1 written here. Then increment, this increment will also be n operations, right? Yeah. After that, inside the loop, there are 2n operations again. Yeah. This takes this takes 2 for one iteration. For n iterations, it needs 2n operations. So overall, if I just add it, then we will get 4n plus 2. In the first it was 2 and in the next it is 4n plus 2. Good. Now in step 3, we have these two loops, okay, one inner loop and one outer loop. You don't need to calculate this. I have already written over here 4n square plus 4n plus 2 operations. And it is very complex, right? Yeah, it is very complex to understand the number of operators used here. So it is tough. It is tough and rough actually. Overall, S1 plus S2 plus S3, we get 4n square plus 8n plus 6 operations or units of time. Okay. Now, let's see. Is it a good way? No, this is not a proper way of analysis of algorithms since we consider every small step of algorithms. Not that good, right? Yeah. Focusing on small details and microscopic steps will take much time to estimate, right? So we consider the bigger picture. What do you mean by that? Bigger picture is that order of magnitude method. Fine. What does it do even? This is an algorithm, same concept. So z equals x plus y. So we will take it as 1 unit of time only. Okay, 1 unit of time. Then a for loop, the same for loop in step 2. Step 2. It takes n units of time because it runs from 1 to n. Easy, right? Yeah, it is. There are two loops over here, one inner and one outer. So it takes n square units of time. Overall s1 plus s2 plus s3 is equal to 1 plus n square. Or n square, we consider n square as the major operation. Okay, the dominant. N square is the most dominant over here. So we choose n square as a solution. So this is what the order of magnitude method does, okay, to analysis of algorithms, and it makes tasks very easy. Now let's deep dive into the most important terms of analysis of algorithms. First is time complexity. So what do you mean by that? Time complexity of an algorithm quantifies the amount of CPU time taken by the algorithm to run as a function of input size. And similarly, space complexity of an algorithm quantifies the amount of main memory space taken by algorithm to run as a function of input size. Now, what the hell are that? So CPU time and main memory space, an algorithm needs both, right? And for good performance, understanding these metrics to estimate or approximate the overall time or space the algorithm consumes is very important. So let's consider an example. We are students, we have many books, notebooks. Okay, fine. This is the notebook. Yeah, it is bad looking, I know. Sorry for that. Now, if you have written any concept in some page numbers that you completely forgot, right? You have to work hard, spend some time searching for that concept page by page. More and more time, isn't it? Exactly. Here lies the importance of an effective algorithm. Okay? What could be an effective algorithm? Think about it. Yeah, if you have thought, then you will get it. An effective algorithm would have been indexing, proper indexing. So if we use indexing or page numbers, then the time taken would have been very less, right? So here lies the importance of evaluation of an algorithm using this time complexity. Okay. Now one example of space complexity. Suppose this guy wants to download ABC games, which is of 1 GB. Now he has a storage of 150 MB and 200 MB something. Okay. So this is not fit for his mobile storage. No. Now if ABC games is made into 100 MB by any algorithm, okay, more optimized way, then less space to be occupied, and this guy be like, yeah, hooray. Here lies the importance of an algorithm having better space complexity. I hope you understand it, right? So here's all, guys. Thank you for hanging in. Thank you. And here's the quote of the day: be a bat, not to scare anyone. Be a bat, eat fruits and hang tight. Be a strong bat you can be. So, thank you. Thank you for viewing this lecture. Great.